Hey, what's up? This is Mr. Santry, and I'm going to guide you through this sheet on chemical equations. I'm going to be your guide, if you will. So, I'm going to first show you the drawn out section. So, in your box here, you should have two different drawings, okay? And they give you the colors for this one. So here, green was selected as iron for your key, green. Blue is going to be aluminum, and red is going to be chlorine. So those are the blocks you're going to make, and then you have, again, your reactants and your products over here. So it looks like the first one you need, since aluminum is blue, is you're going to need just a single blue aluminum piece. Looks like that, right? And it's already drawn down there. You just need to build it. I mean, build in quotation marks because it's a block. And then for your FeCl3, it looks like you're going to need one green and 3 of your red chlorine. So I already made that one, and it's drawn down here, so this should be in your box there, but it looks like this, okay? And then your products, you guys can probably already see for AlCl3, you're going to need 1 of your aluminums and 3 chlorine. So AlCl3, again, that's this one. It kind of looks like this. And Fe is just a lone green iron, okay? So even though this is all already up on the screen, go ahead and put down your own version, and then when you have your blocks made, make sure that the reactants and the products are on the same side. Raise your hand so that a teacher can check you. So go ahead and pause now, finish up what you need to, and raise your hand. And then when you get a chance to, you can go ahead and answer these two about what is different or the same about the reactants or the products. Basically, I can tell you now, basically they're different because even though you have the same elements, they are arranged into different compounds, right? Because on this side you have FeCl3 and that's AlCl3. But they are the same because in this particular one you do have the same amount in each side, atom-wise, but also you just have the same elements. Okay, so go ahead and finish up this first section. Make sure your blocks are built. You do not have to use the same color as the key here, as long as yours makes sense, and then raise your hand. So, we are now on the back side of the paper, and so I have my key here, but it looks like you got hydrogen. I picked blue for that one. For nitrogen, I picked green. For O3, you got oxygen here. I picked a nice red color, right? For sodium, I used orange. And for carbon, I got a nice purple. Now, when you build yours, you do not have to use the same exact colors in the key. You just have to pick 5 different ones, okay? And remember, if you need more of any color, you can just go into the bucket and build them. So, I'd like you to pause here and try to build your molecules on your own. I will give you a hint. Remember that when you see the coefficient, like this one in front of HNO3, you need to make 2 separate molecules of HNO3, okay? So try on your own, pause now, but if you're having difficulties building yours, feel free to unpause and then see the next step. So here is the next step, and I'll show you the ones I made. So for the HNO3, I've got this one, so the blue hydrogen, green nitrogen, 3O3, and then I made 2 of those because of the coefficient, right? You need to have 2 of these. Alright, and then that's plus, again, there is a coefficient in front of NaHCO3. You should have 2 of these, and you can see those 2 in the drawing down here, right? And then here was the HNO3. For the other side of the equation, here's NaNO3, and again, you needed 2 of those, so here's 2 H2O, right? So H2O, there's 2 of those, and then I also have 2 CO2, okay? Now, if yours weren't correct like that, I know some of you are using different colors, feel free to pause here, fix it up, make it look like ours, and then raise your hand and get a teacher to check you. Okay. So at this point, you should have gotten your models checked, okay, and I'm just going to reveal the next part. There's your atom count. So, again, you can just go through these, counting each color of atom, like that. 4, 6. And so, this one, for example, you've got 12 total for oxygen, right? Your sodiums, if I count those, you've got 2, carbon 2, nitrogen 2, hydrogen 4. Again, if you go over it and do that on this side as well, you'll see those were all counted for you there, so you could pause if you need to check your own work, okay? And then looking at these two, comparing them, is this one balanced or not? What do you think? Is it balanced? If you said that it was balanced, you are correct, okay? If you have questions, raise your hand now and ask. So, for the last one, again, you've got 5 different elements you've got to pick. You're going to have K, which is potassium, N, which is nitrogen, O, which is oxygen. You're going to have H, which is hydrogen, and then you've got C for carbon. So, me being totally alone in the room right now, I'm going to just do this myself. I've got, let's see, we'll make potassium blue. I've got nitrogen green, oxygen red. Hydrogen's orange in this one, and then carbon is purple. So, you know, if you don't want to use those colors, feel free to use your own. Just make sure you keep track of it. I'm completely alone here, so I'm going to entertain myself, and I'm using those colors, okay? So again, try to build these on your own. Remember to watch out for the coefficients. You need multiple molecules if it's that. And try on your own. Pause now. If you're struggling with it, view the next part. Alright, so here's my solution. I've got KNO3 here, and here's what mine looks like. So K, N, and then O3. Alright, there were no coefficients, so I just have one of those. And then for the 2H2CO3, here's H2, carbon is purple, O3 is red. And since you had 2, I had 2 of those here, okay? The K2CO3 is going to look like this. Again, no coefficients, so you've just got 1. And then 4HNO3, I know you guys probably thought this one was a doozy, but, you know, me being not around anyone else, there's no one else around me at all, I had the time to make 4 separate molecules, and I didn't feel anything on my head just now. So here's 4HNO3, and I'll circle it for you there, alright? And then as for the atoms, I want you to pause real quick here, and, yeah, actually, pause your work right here and get your work checked by a teacher. Make sure you had the molecules right, okay? So you're back with me now. You got your work checked, right? Don't progress if you didn't get your work checked. And then for this part, here's the atom count that I had. So you had all these on this one if you counted up each color. And for the products, you had this. So is this balanced or not? What do you think? It's so quiet in here. In my room where I'm recording alone right now. Is this balanced? If you said that it's unbalanced, you are correct. Now, for this particular sheet, so apologies for the disruption at the end just there. I had to pause recording because there were some ghosts in the building. But I just wanted to let you guys know that last one, it was unbalanced. You do not have to balance the equation on this sheet, but as you move on to the next thing in Google Classroom, there will be more practice where you do balance stuff. So I need to go and check in with the main office about this issue that we're having. But if you've got questions about any other part of the paper, make sure you got all your models checked. Feel free to ask those. I'll see you later.